Novak. My presentation is going to be on genetic engineering out in agriculture. This article comes from the Union of Concerned Scientists. It's an organization that I found just researching articles on some topics for our class. So a little bit about the Union of Concerned Scientists. They're an organization that was founded in 1959 by scientists and students at the Massachusetts Institute of Technology. That year was the same year as the Vietnam War at its height, and President Cleveland's heavily polluted Clee Hong River was the main issue that caused the start of this organization. Appalled at how the U.S. government was misusing science, the UCS founders drafted a statement calling for scientific research to be directed away from military technologies and towards solving pressing environmental and social problems. The union focuses on clean energy, transportation, food and agriculture, and global warming, and also nuclear powers and weapons. A few of the accomplishments that they have recently done is they played a key role in passing emissions and fuel standards that will cut in half the global warming emissions of new cars and light trucks by 2025. All told, the changes will be the equivalent to taking some 40 million of today's cars and trucks off the road. They also help convince California to require that at least one-third of its electricity comes from clean and renewable sources by 2020. They also won a victory in Congress with the unanimous passage of a bill that explicitly affords whistleblowers protection to scientists and others who expose the distortion of suppression of federal scientific data. Also, the UCS analysts exposed News Corp for extreme misleading climate coverage, showing that Fox News Channel and the Wall Street Journal's opinion page misled on climate science more than 80% of the time. Funding for the Union of Concerned Scientists comes from 98,000 members who provide 71% of its $23 million budget. 23% comes from foundation donations, and the other comes from miscellaneous donations. So as we go into benefits of genetic engineering, I'd like to point out that this article, although it does point out the benefits, it is mainly concerned with the trade-offs of these benefits. So the first benefit is yield increases. The second is reduced fertilizer use. And the third is drought tolerance. And we're going to kind of come back to those at the end. So some of the benefits, for example, the use of herbicide-resistant genetically engineered crops has saved farmers time formerly devoted to mechanical cultivation and spot spraying, but has also driven the consolidation of monoculture farming at a larger scale. Monoculture, by definition, reduces biodiversity, making farmers dependent on chemical inputs rather than natural processes to manage pests and the soil nutrient cycle. Similarly, BT corn has reduced the use of sprayed insecticides, but its adoption has coincided with sharp increases in the use of neo-in-content seed treatments, which have been tied to declining populations of birds and beneficial insects such as honeybees. And as with herbicide-tolerant crops, the benefits of BT corn are being eroded as pest insects develop BT resistance, forcing farmers to look for other potentially more toxic options. which I listed earlier, yield increases, reduced fertilizer use, and drought tolerance have yet to materialize or have been relatively small magnitude, as the UCS analyst has shown in the trilogy of reports. And while some scientists and others point to brighter future with genetic engineering, um, other brighter future in which genetic engineering will make a unique and major contribution to agriculture, the reports do not find that current science supports such claims. So as stated earlier, this is the section of the negative on genetic engineering, although some of them were listed above with the benefits, but that's part of this article's perspective. So um, genetically engineered crops can potentially cause environmental problems that result directly from engineering traits. For instance, an engineered gene may cause a uh, genetically engineered crop or wild relative of that crop to become invasive or toxic to wildlife. The most dangerous impact of genetic engineering in agriculture so far is the phenomenon of pesticide resistance. Millions of acres are now infested by weeds that have become resistant to herbicides. The overrun or the overuse of Monsanto's Roundup Ready trait, which is engineered to tolerate the herbicide, has promoted the accelerated development of resistance in several weed species. So, looking for ways to fight these super weeds, as they're called, farmers are turning to older, more toxic herbicides, such as the 2 and 4D and di the dicamba as so to develop new genetically engineered crops to tolerate these older herbicides, um, with no guarantee that Roundup will not repeat itself. And this issue is not confined to herbicides. Recent reports suggest a growing problem of corn rootworm resistant to insecticide beet, which some corn varieties have been engineered to produce. And as the super wheat crisis illustrates, current applications of genetic engineering has become a key component of an unsuitable approach to food production. Um, the article now moves on to a different approach to farming, which I'm going to talk more about in the next slide. But the UCS calls this healthy farms. This approach doesn't use products, but is more focused on new processes. So in the case of genetic engineering, better solutions include crop breeding, often assisted by molecular biology techniques, and agroecological practices such as crop rotation, cover crops, and integrated crop livestock management. Um, so such healthy farm practices are the future of U.S. agriculture, and policymakers can help speed the transition by supporting research and education on them. So what can be done? Um, the goals are reducing dependency on pesticides and herbicides. Um, there's clearly alternatives to many biotechnology products. Many of these alternatives are not products, however, but instead systems and methods of sustainable agriculture. The main the main example I'm going to focus on is crop rotation, which keeps pests under control, which keeps pests under control by depriving them of the continuous food supply they need to build up large populations. Some of the other advantages of crop rotation include controls a broad variety of pests rather than just one or two. It does not select for resistant genes, as do chemical toxins or genetically engineered crops. It does not result in ongoing pollution of water or air. As a pest control strategy, crop rotation is far preferable to both chemical insecticides and genetically engineered crops. Unfortunately, because it involves processes and not products, there is no industrial constitution. There's no industrial belief to develop and support crop rotation, as there is no products of biotechnology involved. Um, to me, this basically is just saying that since there is no profitable interest for companies that develop these type of products, there is going to be no money put into researching or implementing these types of systems. Um, so new products are less important than new knowledge and new ways of managing agricultural ecosystems. Um, so does the Union of Concerned Scientists have a position on genetic engineering? Um, before I actually read this section, if I had, I already had said yes because it's pretty clear based on how the article is written that they have a clear stance on it. But I will go into a little bit more detail of what their stance is. So um, they understand that technology is potentially beneficial and supports advances in molecular biology, which is the underlying science, but they're critical of the business models and regulatory systems that have characterized the early development of these technologies. They have proved valuable in some areas, as in the contained use of engineered bacteria in pharmaceutical development, and some genetic engineering applications could turn out to play a useful role in food production. However, genetic engineering applications in agriculture have only made the problems of industrial monocropping worse. Rather than supporting sustainable agricultural and food system with broad social benefits, the technology has been employed in ways that reinforce problematic industrial approaches to agriculture. Policy decisions about the use of genetic engineering have too often been driven by biotech industry public relations campaigns rather than by what science tells us about the most cost-effective ways to produce abundant food and preserve health of our farmland. So I'm going to go over these 5 policies that they would best believe that would best serve public interests. The first is expand research funding for public crop breeding programs. This would allow a broad range of non-genetic engineered as well as genetically engineered crop varieties to remain available. We also need to expand public research funding and incentives to further develop and adopt agroecological based farming systems. So instead of using money to fund research for genetic engineering and new products, we should have more public research for better ways to farm instead of trying to develop new products for profit. Third is to take steps such as changes in patent law to facilitate independent scientific research on genetic engineering risks and benefits. The fourth is to take a more rigorous, independently verified approach to genetic engineering product approvals, so that the products do not come to market until the risks and benefits are understood and non-biased review. Excuse me. The fifth is to support food label laws. This would require foods containing genetic engineered crops to be clearly identified as such so that consumers can make informed decisions about supporting genetically engineered applications in agriculture. So before I answer my discussion questions, I think this article is very informative, although it is very one-sided and it doesn't explain fully, I believe, the benefits of some genetically engineered products. I know that it definitely has improved production and the amount of food that we are able to make as a country and as an industry. I also believe that they did not fully take into account the risks of using such very effective so that we can continue to feed our ever-growing population, our ever-growing human population. Um, the, for the second question, should the government support research of GE or sustainable practices? I believe that we should research both fully and try and maybe even combine them as best we could. I think science is definitely an asset in any field, so we need to use it to the best of our abilities. The third question, what policies would you implement to help the agro industry? I would like to see some type of help for farmers or subsidies that use sustainable farming and switching off the types of genetically engineered products that are really have been proven to hurt the earth and the people on it. The fourth question, should producing food be a bottom line business? I think I don't think it should. I think that food is something that should be readily available to everyone. I know that in our society there's many different types of food and expenses of food, and that affects what type of food people buy and what is available to people. But I think that we should switch more to fresh food being available to people that truly need it. Um, I think that some companies like Monsanto have made food a bottom line business, and it is proven to be detrimental to our society. Um, and I think there is a way to make profits without negative effects on the environment. I've heard of many